So moving right on to the next company in our list, we have Chuck Gershman with Owl AI. Hi, Chuck. How are you this morning?
Good morning. I'm doing well. How are
Good,
you?
good, good. Very good, very good. Thanks for joining us. Couldn't get in the investor that we had in mind to give a brief introduction of Chuck, so I'll do it myself. But really interesting technology that they're using. I will not spoil it or ruin the description, but I really love the take on perception. So this is our first startup that we're presenting today, focused on perception, but all of them take a really different tack at it. And Chuck with his team at Owl AI is looking at thermal ranging solutions for perception. So with that, Chuck, I will let you share your screen and take it away.
Okay, let me know when you can see my screen.
We can see you and we can hear you just great.
Perfect. So let's get started. So once again, my name is Chuck Gershman, and I am the CEO and co-founder of Owl Autonomous Imaging. So as was just stated, we develop a 3D thermal computer vision sensors and software solutions with the goal of supporting ranging for industrial, defense, and automotive mobility applications. At Owl, everything we do is about making the world a safer place. So when it comes to mobility, Owl believes that safety starts with perception. So to that end, let me show you what the more or less state of the industry is in perception today. So I'm going to show you a little video here. So this video shows third-party testing of various production cars that all claim to have advanced automatic braking systems. And as you can see, these systems do not perform well when it comes to pedestrians. Now, a few of the models did stop in time for pedestrians, but every system tested, irrespective of the manufacturer, all demonstrated one chilling characteristic. And specifically, that characteristic was that at night, every system tested was found to be completely ineffective with a 100% failure rate. So these are production vehicles that you can buy today with automatic braking systems, but they will not stop for pedestrians at night. So here's a little bit about what we do at Owl to address that problem.
At Owl Autonomous Imaging, we're all about safety. We use thermal imaging and custom thermal ranging software that allow us to detect pedestrians and range to them and locate them for autonomous automobiles so that we can have automatic emergency braking for pedestrians and to save lives.
Adding a thermal camera to an automobile for safety purposes extends the range of operation over using just visual cameras.
There are lots of low-light cameras, but thermal imaging is a no-light camera. So it can see pedestrians, it can see cars, it can see buildings at night with absolutely no light.
We combined an advanced thermal imaging camera with custom optics and artificial intelligence machine learning software to produce a 3D thermal image for use in automobiles to make driving safer.
We're an input to the system to tell it where there's a threat. The car will decide, hey, there's a pedestrian or animals, and either steer away from it or brake. Radar and LiDAR have difficulty with pedestrians between parked cars because they see the car first and they don't see the pedestrian. And because we're thermal, pedestrians really pop out of the image. There's no difficulty finding pedestrians or deer behind bushes. Anything that's warm-bodied just really pops out of the images. Our main target market is automotive, ADAS, and AV, but it also could be applied to other existing markets such as first responders, firefighters, and search and rescue. Obviously, it's always a good thing if you can save a life.
Today, in the United States alone, 6,000 pedestrians will be killed by cars. 76% of those pedestrians will be struck in poor lighting conditions, so nighttime or dusk or dawn. And the numbers are not decreasing. We solve that problem. We save lives, save lots of lives.
All right, so that gave you an idea of what we do and a little bit about how we do it. But just a little bit about why this problem even exists to begin with. So as Gene mentioned in the video, radar and other sensors work together, but they fail to see pedestrians. So why is that? Well, today's automotive safety systems rely on a data fusion usually from a visual camera and a radar to initiate the braking decision. The camera and radar are completely dependent on each other to produce the 3D location data set viable for pedestrian braking. The sensor fusion must deliver object identification, the exact location, along with the trajectory. And if either sensor has a miss, the sensor system will fail. And this is no longer acceptable, as we're now seeing regulations in Europe and elsewhere where the requirement for pedestrian and cyclist automatic braking systems, and add motorcycles to that, are now going to be required functionality. So let me show you one more video where I'll just manually walk through this. So first off, this was shot in a busy parking lot at a shopping center in the evening using one of our Thermal Ranger cameras. The image is normally in grayscale from the thermal camera. The color that you see here has been added by our computer system AI. And it's not just to pretty up the image. The rainbow type effect that you see here actually represents range. So you have oranges in the near field and greens, and you'll see some darker blues and blacks as you get into the far field. Now this was shot from a moving vehicle. So let's just play the video quickly. And you'll see that the car is moving, and we've put bounding boxes around cars and bounding boxes around pedestrians. Again, computer generated by our AI. And we've annotated the actual distance measurement from the car to the pedestrians, and that's what these data boxes are showing here. And we'll just play it real quick. And again, color is depth, and then we've annotated depth specific to the pedestrians. All right, I'm going to stop there and back up 1 second and just show you something real quick. Notice this pedestrian here on the left, and notice he has a box and a distance, and he's dipping between two vehicles. But the computer is still picking him up because of the contrast and the resolution of the camera capability. Let me go back there. You can see that we can still, even when the individual is about 80% occluded, he is actually still detectable and measurable by the system. This is something that a LiDAR or radar system would be incapable of doing. All right, now I'm going to show you one more video here. This one's kind of self-explanatory, again, shot at night. Here we were looking for training data for large animals, and we were out on the road looking to collect the data. On the left-hand side is a 4-megapixel RGB camera that was connected to the vehicle, and side by side with our Thermal Ranger. Now again, this was in 2D. We were collecting data, so we don't have the computer AI running on top. We were looking for the data sets. But again, as you can see, let's just one more time here. Notice that we have a deer in the road on the right. There is a deer on the road on the left. We can't see it. We have 3 deer on the side of the road. Now 4 deer, and they're running away from the car. They're completely invisible to the camera. And by the way, they were also completely invisible to the driver himself. So the thermal was quite beneficial in this case. Now, in addition to nighttime operation, all of these degraded visual environments that are shown on this slide are all detectable by a thermal camera. So rain, fog, snow, smoke, dust, glare, and the identification of animals and debris are all things that thermal cameras can do where visual cameras are challenged. Our target markets include automotive, specifically safety in automotive, industrial heavy equipment and mining, traditional thermal markets, and government and defense applications. All this adds up to a massive market opportunity with a $10 billion SAM and a 37% CAGR. Okay, so let's jump to what makes us unique and what's driving our traction in the market. First of all, what we just showed you is an example of the only monocular 3D thermal imager available in the world. No one else generates range in the infrared domain, in any infrared domain, using a monocular camera. We also are introducing the first high-definition megapixel thermal sensor at commercial price points for commercial application, and soon we'll have a thermal sensor at the price of visible. From a traction perspective, we have early revenue coming from mature markets, including 2D thermal, heavy equipment, government, and defense. And we have relationships with all of the folks shown here We have paid revenue coming from those with green arrows, and business relationships with those with yellow. But the billion-dollar opportunity comes from the automotive safety market, where a single design win with a tier one automotive can beget numerous OEM design wins. And again, the check marks demonstrate or denote existing relationships and business relationships. Within defense, we've already secured over $3 million in contracts with another $800,000 in the pipeline for off-road applications, specifically with the U.S. Army and the National Science Foundation. I should highlight that for defense applications, our solution is completely stealthy. And you can see the testimonial I pulled out from one of the soldiers that evaluated our solution. I wish I would have had anything close to this on any of my deployments. This would have saved a lot of heartache. We also have secured a strategic partnership with Teledyne, the largest thermal camera supplier in the world. This partnership includes multiple components. So we have a joint development component at the sensor level. We have a supply agreement where Teledyne becomes the high volume manufacturer of our sensor and also produces our cameras for us in 2D. And then we use the camera and sensor technology to penetrate the mobility market shown here. But Teledyne also has rights to resell our technology into existing markets, which provides a royalty and licensing revenue stream back to the company. So existing 2D markets where Teledyne already has a large global footprint, we are designed in as their next generation sensor technology. So what's this look like from a business model point of view? Three basic silos of business. We have off-road opportunities, which, as I said, we already have contracts here. We have traditional thermal camera market opportunity, which is Teledyne DALSA, and then our business model for automotive is actually a kit. So we don't actually sell the end camera. We actually kit and provide a sensor solution, optic, and software, and help tier ones to design a camera system for automotive OEMs specific to our technology. Again, the three unique components that underlie what we do from a technology point of view are our HD sensor chip, our unique optics, and again, our computer vision AI software suite, which in our soon will be producing 61 million points of range data per second. Our patent portfolio is significant with 15 issued patents and another 6 pending, and we have 3 in draft. You can see how the patents are laid out across an idealized architecture. From a competitive point of view, again, we're the only sensor that supports both object identification and location in infrared. We do it in thermal, but across any infrared spectrum. Our competitors only support 2D detection. Aspects of quality that set us apart are resolution, frame rate, sensitivity, dynamic range, and field of view. Now, a little bit about our team. Personally, I've been a CEO for 14 years at multiple companies. I've had successful exits with sales of companies to Intel, PMC, Sierra. I've raised $160 million in financing, and I've sold $500 million of high-tech product sales. My partner, Gene Patilli, was a member of the original digital imaging team at Kodak that developed the first commercially available digital camera. And he spent 30 years building cameras and sensors. Gene and our team have 2 thermal cameras in outer space today, monitoring the Earth. And Pete Rudak led engineering, our VP of engineering, has led engineering teams of over 500 people and been part of the management team of a $4 billion business unit. Here's a quick look at our pro forma revenue with associated gross margins. So we maintain a very, very nice gross margin capability, again, because when we sell cameras, we're selling cameras into higher margin opportunities and into the more challenged price points, we actually kit and have a more of a component-based model similar to a semiconductor company, not a systems company, and that allows us to maintain our margin. Since inception, we've done $4.3 million of revenue. That's both build and backlog to date. So finally, why are we here today? Well, basically, we have three distinct asks. One, we're looking to continue to grow our OEM and Tier 1 automotive relationships. And so we're always looking to talk to people along those lines. We're interested in additional ground vehicle partnerships within the federal marketplace. So working with system integrators, so not just the Army, but those that supply the Army. And finally, we're nearing closure of our Series A equity round. And we're doing a $15 million round. We have an allocation of about $3 million left that we can top off. The rest of it is called for. So that's also why we're here today. And to wrap up, I wanted to highlight that our business model was developed as a low-risk, high-reward buy construction for our investors. Our early traction, as I've just described with DoD, Teledyne, and other providers, provides us an assured, stable, steady growth. So as we stand today, we're a solid 2 to 3x return on investment just with the business and the capabilities that are in place. But we can deliver hyper growth to our investors sometime, and what unleashes hyper growth for us is the ADAS safety take-up rate. So it's not a matter of if on this, it's a matter of when. And when we hit this take-up rate, our ROI jumps from a 2 to 3x ROI to an 8 to 20x ROI. And that's really the value to investors. So with that, I'll say thank you and take questions.
Wonderful. Thanks a lot, Chuck. Do we have any questions from the audience?
As usual, I have a lot of questions, and I guess I'll jump in unless others have questions. So, Chuck, it sounds like you have a multifaceted go-to-market plan. Can you talk a little bit about which of these verticals are you an incremental solution, and which ones might you be a replacement, if any? I mean, are you a replacement for anything, or are you additive?
Okay, so I guess I'll work backwards from the automotive safety market back into the other solutions,
Right.
or other markets. So yes, for automotive safety, we're additive, right? We're not proposing that you replace cameras and radar with our sensor. We're proposing that you supplement it. So we are a camera. We're just not a visual camera. So we're not. So if you add our camera to visual camera systems, you get a broader capability in terms of environmental usage model, and that just gives you a better performance of the overall system. But then when you fall back to like the defense application for off-road, yes, in that case we can be used as a singular sensor system. The problem with off-road from a defense perspective is that LiDARs and radars are tracking systems that will allow for enemies to detect the emanating source of the energy and actually target them. So we're a passive system, so we can deliver the perception without giving up our position. If you're using us for off-road industrial application, you might replace you more than likely would replace the visual cameras with our cameras, but you'd still leave radars in the system. So it depends on the end market as to whether we're a full replacement or a supplement. And then in the 2D applications that we talked about, these are thermal systems that already exist. We are replacing that with a higher performance megapixel capability. So that's a true replacement.
Okay. And then second question or related questions. So can you talk a little bit about the form factor for your cameras? How big are they? How heavy, et cetera? And also, what's your estimated cost curve in terms of the next few years?
Yeah. So as you saw in one of the videos, basically you can hold the camera in your hand. The lens is less than an inch is the total lens across. So that would be the area that would be visible to the outside world. And the total camera's about an inch and a quarter square. So they're tiny little things, and you saw that in the video. And they're also quite lightweight, given that they're quite small. For target price points, so for off-road and industrial applications where we're using them in lower volumes, these things are these systems are $1,000 to $1,500 systems. But for automotive applications, where you can get to higher run rate in terms of units, our target price is a resale price of roughly $300 to the OEM. So that's what General Motors or Daimler Benz would be paying for the full system, about $300.
Great.
And we have a roadmap to drive that price down to $200 with some enhancements that we're making in a couple of years.
Excellent. Well, as you will have seen from the list of attendees from our event, there are quite a few OEMs and other corporates coming. So hopefully you'll have some good discussions.
I look forward to it, and really looking forward to joining you in Santa Cruz. Look forward to it.
Excellent.